Namaste everyone. Atoms and molecules. Introduction. We have learnt in our lower classes the matter is around us everywhere. What is matter? Matter is made of atoms and it has a mass and it occupies space. Curiously, the idea of atom was first proposed by Greek philosophers in the 5th century, but their theory was more philosophical than scientific. So, the first scientific theory of the atom was proposed by John Dalton. Few of the few of the postulates of Dalton's theory about an atom were found incorrect by the later on studies made by J.J. Thomson, Rutherford, Niels Bohr, and Schrödinger. So, in the light of the result of the researchers, most of the limitations of the Dalton's theory were removed and a new theory known as the modern atomic theory was put forward. The main postulates of modern atomic theory, which is given by Henry Moseley, are as follows. Number 1, an atom is no longer indivisible. After the discovery of electron, proton, and neutron, they are subatomic particles. Number 2, atoms of the same element may have different atomic mass, which is called isotopes. Okay, the same atomic number but different in mass number. Discovery of isotopes, the example is chlorine 17, 35 mass number, and chlorine 17, 37 mass number. Number 3, atoms of different elements, which is different atomic number, may have same mass number, atomic masses or mass number, both are same. Discovery of isobar, which means the bottom will be different and the top will be same. Okay, here the isotope, the top will be different and bottom will be same. So in isobar, the argon 1840 and calcium 2040 both are having same mass number but different in atomic numbers. The next point, atoms of one element can be transmuted into atoms of other elements. In other words, atom is no longer indestructible. Discovery of artificial transmutation. Atoms of one element can be transmuted into atoms of other elements by artificial transmutation. The next one, atoms may not always combine in a simple whole number ratio. For example, glucose, the molecular formula of glucose is C6H12O6. C6H12O6. Here, the ratio of carbon with hydrogen and oxygen is 6 is to 12 is to 6, which is, if 6 is to 12 is to 6 means, which is divisible by 6 children, so we'll get 1 is to 2 is to 1. Okay, and sucrose, if we take sucrose, the formula is C12H22O11. The ratio will be, the ratio of carbon, hydrogen and oxygen will be 12 is to 22 is to 11. Here they are even numbers, this is odd number, and all the three numbers are different, which cannot divisible by one number. So we have to keep the same. So the atoms may not always combine in a simple whole number ratio. It may not give simple whole number ratio like glucose. Okay. The next one. The mass of an atom can be converted into energy, which is Einstein's equation. E is equal to mc square. E is equal to mc square. This is the energy converted into mass of an atom, or mass of an atom can be converted into energy, which is E is equal to mc square. Here E is energy, m is mass, as we know. What is c here? Speed of light. C is called speed of light. The value is, do you know what is the speed of light? Which is 3 into 10 to the power of 8 meter per second. The distance travelled by light in 1 second, which is 3 into 10 to the power of 8 meter, which is 30 crores meter per second. Okay, that is the speed of light. Thank you, children. The next one is the modern atomic theory is the basis for all the studies of chemical and physical processes that involve atoms. You have studied the most fundamental ideas about an atom in your lower classes. Let us discuss some more concepts about atoms in this lesson. Atom and atomic mass. In this paragraph, we are going to learn atom and atomic mass. Atoms are very smallest particle. Atoms are very smallest particle, okay, and which we cannot see through our naked eye. It can be seen only through microscope. Okay, so atoms are the building blocks of matter. Since matter has mass, it must be due to its atoms. According to the modern atomic theory, an atom contains subatomic particles, which is protons, neutrons and electrons. As I told you earlier, so if this is an atom, the inside is nucleus is present. Okay, so inside the atom, which is pen is there. What is pen? Protons, electrons and neutrons. And the last two alphabet will be in center in nucleus, and this electron will be revolve around the nucleus. The protons are positive in charge and electrons are negative in charge. Neutrons have no charge. Approximately, protons and neutrons have a mass which is 1 AMU, which is equal to 1 AMU. What is AMU? Atomic mass unit. What is atomic mass unit? Mass of 1/12 mass of carbon 12 atom. 1 AMU, which is equal to 1/12 of mass of carbon 12 atom. Do you know what is the mass of carbon 12 atom? Yes, it is 12. Okay, so if I put 12 here, 12 will be cancelled. I'll get 1. So 1 will be the mass of protons as well as neutrons. In the case of electrons mass, which is very less mass, so it can be negligible. It can be negligible. So protons and neutrons are present inside the nucleus. They are the in charge for their mass. So mass number means what? The number of protons and number of neutrons will be get mass number. What is atomic number? Atomic number, which is equal to number of protons or number of electrons. Okay. So the sum of the number of protons and neutrons of an atom is called its mass number, as I told. Individual atoms are very small. It is difficult to measure their masses. You can measure the mass of macroscopic materials in gram or kilogram. The mass of an atom is measured in atomic mass unit, which is called AMU. What is AMU? 1/12 of the mass of carbon 12 atom. An isotope of carbon which contains 6 protons and 6 neutrons. Carbon 12 atom, we can write it like this. This is called atomic number. This one is called mass number. This mass number, what are the subatomic particles are in charge for their mass number? Protons and then neutrons. How many protons are present here? Here the atomic number is nothing but the number of protons. So what is the remaining part? 12 is there. If 6 is protons means the remaining part will be neutrons, which is 6. So there are 6 protons and 6 neutrons in carbon 12 atom. The symbol AMU is no longer used in the modern system and instead it uses the symbol U. It denotes, instead of AMU, we are using U. It denotes unified atomic mass. Unified atomic mass. The mass of a proton or neutron is approximately 1 AMU. Already I told. Yes. The next we are moving to relative atomic mass. What is relative atomic mass? Relative atomic mass of an element will give the approximate value only, not an accurate value. Here, As an atom is very small, its absolute mass cannot be determined directly because the atom is very small. The early pioneers of chemistry used to measure the atomic mass of an atom relative to an atom of another element. So early pioneers, what they have done, they have taken a standard mass of one element and they found the another element's mass number using of that standard element. So they measured the masses of equal number of atoms of two or more elements at a time to determine their relative masses. They have taken the equal number of atoms present in an element. For example, first they have taken hydrogen scale. Hydrogen they have kept it as standard and they found the other element's mass number. They established one element as a standard, gave it an arbitrary value of atomic mass and using this value they measured the relative mass of other elements. The mass obtained by this way is called relative atomic mass. What they have done? One element as a standard, gave it an arbitrary value to that element of atomic mass and using this value they measured the relative mass of other elements. First they have taken hydrogen. Hydrogen atom was chosen as a standard and masses of other atoms were compared with it because of the existence of isotopic character. What are the isotopic character of hydrogen? Yes, 1H1, 1H2, 1H3, which they are called as isotopes of hydrogen, which is the first one is called protium, the second one is called deuterium, the third one is called tritium. Later, hydrogen atom was replaced. Because of its isotopic character, the hydrogen atom was replaced by oxygen atom as a standard. Now, the stable isotope of carbon, which is carbon 12 with atomic mass 12, is used as the standard for measuring the relative atomic mass of an element. So, what is the definition of relative atomic mass? Relative atomic mass of an element is the if an element is having two or more than the isotopic character, if it is having, we have to take the average. Okay, what average? We have to take mass of an element. Okay, here the relative atomic mass of an element is the ratio between the average mass of its isotopes. Yes, average mass. If I take hydrogen, protium, deuterium and tritium, okay, both of the three of them are having same atomic number but different in their mass number, so they are called isotopes of hydrogen. Okay, so what is relative atomic mass of hydrogen? I don't want this protium, deuterium, tritium. I need only hydrogen's atomic mass. Then what will be the atomic mass of hydrogen? We have to take the average mass. Average mass of its isotopes. 2. Which standard scale we have taken? Carbon 12. So, 1/12 part of the mass of a carbon 12 atom. As I told earlier, 1/12 of part of the mass of a carbon 12 atom. What is the mass of carbon 12 atom? 12. 12 is the mass number. As 12 will be cancelled, we'll get only 1 in the denominator. So, we'll get an average mass which is 1 plus 2 plus 3 divided by 3. Yes, I will get 1. The average atomic mass of an element which gives hydrogen isotope as 1 hydrogen 1, 1 hydrogen 2 and 1 hydrogen 3. But I need only 1 hydrogen. So 1 hydrogen take the average mass. Average means we have to add these 3 and we have to divide it by 3. So we will get 1 plus 2 will be 3, 3 plus 3 will be 6, which is 6 by 3, which is equal to 2. This is in the case of hydrogen. But hydrogen is not having 2 atomic mass. It has 1.008 is the accurate value of atomic mass of hydrogen. So what will be the definition? Relative atomic mass, which is equal to average mass of the isotopes of the element divided by 1/12 of the mass of one carbon-12 atom. Modern methods of determination of atomic mass by mass spectrometry uses carbon-12 as standard. Mass spectrometry uses carbon-12 as standard. For most of the elements, the relative atomic mass is very closer to a whole number. The relative atomic mass is very closer to a whole number and it is rounded off to a whole number to make calculations easier. For example, now I told hydrogen's mass number is 1.008. 1.008 is closest value to 1 only. So, the mass number of hydrogen will take it as only 1. For calculating the mass number easier, okay, so we can take the mass number of hydrogen as 1. Here, relative atomic mass of elements in carbon-12 scale as given here, which is hydrogen is a symbol H and it has only one atomic number. As I told, hydrogen's atomic number is 1, mass number also 1. In the case of carbon atomic number is 6, the mass number is 12. How to remember this? We have to double this atomic number. That's all. Next is nitrogen. Nitrogen is a 7th atomic number. The mass number will be 14. How can we remember? Yes, we can double the atomic number. We will get 14. The next one is oxygen. Oxygen is 8th atomic number. The mass number will be 16. What can we do? The same, we can double this atomic number. We may get 16 as the mass number. The next one is sodium. Sodium is 11th atomic number. When we double it, we will get 22 only. We will get 22 only. But 22 is not the mass number of sodium. We have to add 1. So, 23 is the mass number of sodium. So, if the atomic number will be in single, that is odd number, we can make it double and we can add by 1. The next is magnesium. The atomic number of magnesium will be 12. So this is even number. So we can make it double. We'll get 24 as the mass number. And then sulfur. Sulfur is a 16th atomic number which is even number. So we can double this value. We'll get 32 as the mass number. That's all. Children, here I want to tell one thing. If the atomic number is odd in number, okay, 11, 13, 17 like that, you have to make double and then you have to add 1 also. Next is relative atomic mass is only a ratio, so it has no unit. The atom is having unit which is called atomic mass unit. Nowadays, instead of atomic mass unit, we are using unified mass unit. In the case of relative atomic mass, it is only a ratio, so it has no unit. If the atomic mass of an element is expressed in grams, if the atomic mass of an element is expressed in grams, that is called gram atomic mass. For example, gram atomic mass of hydrogen. Gram atomic mass, which is hydrogen atom. Okay, how many atoms are there in hydrogen? Only 1. So, the gram atomic mass will be 1. The number of atom will be 1 into the mass number of hydrogen will be 1. So, we will get 1, the finally gram, because if it is expressed in gram atomic mass, we have to write here 1 gram. Let me go next one, the carbon. Atomic mass of carbon is 12 because carbon is a sixth element. The atomic mass will be 12. So, if I want to write, simply I need to write C. So, which is having only one atom. If there is a no number in the subscription, we have to note it as 1. The number of atom will be 1 and the mass number is 12. So 1 into 12 will give 12 gram, which is the gram atomic mass of carbon. The next one is gram atomic mass of nitrogen. Let us take nitrogen. It consists of only one atom. If the nitrogen is having only one atom, so the gram atomic mass will be 1 into the nitrogen mass number will be atomic number is 7. So this is odd number, children, but we cannot add by 1. We should double the value, that's all. Only 14 is the mass number. So 1 into 14 will give 14 gram. This is the gram atomic mass of nitrogen. The next one is oxygen. Oxygen is 8th atomic number and the atomic mass will be 16. If we double this value, we will get 16. So, the atom, how many atoms are there? Only one atom because no number has mentioned down in the subscription. So, the number of atom is 1 and the mass number is 16. So, we will get 16 gram. This 16 gram is the gram atomic mass of oxygen. Are you clear? Shall we move next? Next is average atomic mass. Yes, we have discussed relative atomic mass, the relative atomic mass which gives the whole number to make calculations easier. The average atomic mass, we have to give the exact value, the accurate value. Okay, let us see how can one measure the atomic mass of an element. It is somewhat more complicated because most of the naturally occurring element exists as a mixture of isotopes, each of which has its own mass. Thus, it is essential to consider this isotopic mixture while calculating the atomic mass of an element. The property of an element will be same, but the atomic mass, the mass which means weight, the weight of the element will be different. So, they have kept it as isotopes because of existence of 3 different mass number. They have kept it as isotopes of hydrogen, isotopes of oxygen, like that. But we cannot write the isotopes in the periodic table. While we are writing, we can mention any one element only. For that one element, what will be the atomic mass? That we have to calculate from its isotopes. Let us see. The average atomic mass of an element is the weighed average of the masses of its naturally occurring isotopes. So, from naturally occurring isotopes, we are going to find out the mass, the exact mass of that element. But the abundance of isotopes of each element may differ. For example, if oxygen is there in earth, but the isotopic character of oxygen, just I am going to take it as oxygen. One is 16, the other one is 17. I am going to take. This is for example only. Okay, oxygen 16 is having 90% in this earth, but 17 is having only 10% only. Then what will be the exact atomic mass of oxygen? How to calculate this? Let us see. The abundance of all these isotopes are taken into consideration while calculating the atomic mass. If we want to calculate average atomic mass of an element, definitely we need the consideration, that is abundancy of all isotopes. Then what do we mean by a weighted average? Let us consider an element which exists as a mixture of, this is the example which they have given, 50% of an isotope having mass of 9 AMU and 50% of another isotope having a mass of 10 AMU. Some element, I don't know that element, so I want to put X and Y. The first, the one element having isotopic character, the first one is 9 AMU. Okay, the mass number is 9 and the next one is mass number is 10 AMU. They having same atomic number, different in mass number, and both are having 50% and 50% in the earth. So, how can we calculate the average atomic mass? Here, as we know, the mass number 10 and mass number 9 will indicate boron, because the mass number 9 and the mass number 10 is nothing but the fifth element. What is the fifth element? It is boron. That's all. Here, its average atomic mass is calculated by the following equation. Average atomic mass is equal to mass of first isotope. This is the first isotope and this one is the second isotope. What is the mass of the first isotope? Yes, it is 9. So first we have to write 9 and into, that is a multiplication. After that, how many percentage abundance? The percentage abundance of this 9 AMU isotope is 50%. That's all. The first one is completed. We need the average atomic mass, so we have to add this, right? So I need to put plus here. The next step, I need to write the atomic mass of the next isotope, which is 10, into how many percentage abundance, which is 50%. That's all. The next we are moving to, we can write that expression as 9 into, how did we get 50 by 100? Because 50% is called 50 by 100. So, instead of 50%, I have written 50 by 100 plus 10 into 50 by 100. That's all. 1010 will be cancelled. 5 by 10, which gives 0.5. 0.5, because in the denominator there is 10. So what will happen? The whole number 5, the point will move front. So 0.5. When it divide, the whole number is divided by 10, we will get a decimal which is 0.5. That's all. So we may get here 9 into, 9 is already there. 9 is the atomic mass of first isotope, and 50 by 100, now we got 0.5 plus 10 into, again 50 by 100 will get 0.5. So 9 into 5, make it whole number, and then you just remove the decimal while you are multiplying. 9 5s are 45. So the after digit only, so after this point decimal only one digit is there, so one digit we have to move front, so we will get 4.5, and then plus here 10 into 0.5, forget this decimal and think this as 5, so 10 into 5 we will get 50. After that, after multiplication is gets over, this point, the decimal is how many digits are there next to the decimal? Only one digit. So one digit we have to move front. So I will get 5 divided by 5.0. 5.0. Sorry, this is not 5 divided by, which is, I got 50 here. If I put point, I will get 5.0. So in the case of first one 4.5, after that 5.0. So the totally 5.4 plus 5, which is 9. So I got the average atomic mass of boron, which is equal to 9.5 AMU. 9.5 AMU. Clear? Yes. Next is note. In the calculations involving percentages, you need to convert percentage abundance into fractional abundance. That will be easier to calculate. For example, 50% is converted into 50 by 100. After 50 by 100, what you have to do, don't make it to divide. Yes, there is 2 zeros in the denominator, so the decimal will move 2 digits front. So we will get, this is whole number, from this whole number the digit will move 2 digits, the decimal will move. So I will get point here, and then after the decimal I will get 0.50, which is equal to 0.50, or else we can write it as 0.5. The atomic masses of elements given in the periodic table are average atomic masses. The atomic masses, you can see the periodic table in your book. All the atomic mass of an element are average atomic masses. Sometimes the term atomic weight is used to mean average atomic mass. Instead of average atomic mass, sometimes atomic weight is also used. It is observed from the periodic table that atomic masses of most of the elements are not whole numbers. So that if you are having any doubt, you can see the periodic table in your book. For instance, the atomic mass of carbon given in the periodic table is 12.01 AMU, not 12 AMU. The reason is that while calculating the atomic mass of carbon, both of its natural isotopes such as carbon 12 and carbon 13 are considered. Yes, so the natural abundance of carbon 12 and carbon 13 are. Again we want to calculate the atomic mass of carbon from its isotopes. The carbon isotopes are, one is carbon 12, the other one is carbon 13. The natural abundance are 98.90 is carbon 12 and only 1.10% is carbon 13. So the average atomic mass of carbon is calculated as follows. Average atomic mass of carbon is equal to, what is the isotopic character of carbon? They have given 2. One is carbon 12, the another one is carbon 13. So both are having atomic number is 6. So first we have to write the atomic mass, which is mass number 12 into. Yes, 12 into what is the percentage abundance? Which they have given 98.90 percentage. Over, after that plus, because we are going to calculate the average atomic mass. So definitely you have to put plus there. We have to add. And the next one is the 13 atomic mass is having 1.10 percentage. That's all. In the next line, we can write 12 into 98.90 percentage. If percentage is there, what is the meaning? Divided by 100. 98.90 by 100. Here 1.10 by 100. Divided by 100 means what? That is percentage. Percentage means divided by 100. We are going to take that value for 100. That is called percentage. Right. So we can get 12 into 98.9 by 100, 13 into 1.1 by 100. For example, here 12 into 98.9 divided by 100 is there. So don't try to divide this. Okay. The denominator is having 2 zeros. So the decimal will move front 2 digits. This is 1 digit. After that 2 digit. That's all. Here the decimal will come here. 12 into what we will get? 0.9 989. That's all. Plus, the next one is 1.1 divided by 100. 1.1 divided by 100, which means the denominator 2 zeros, the decimal will move front. How many digits? 2 digits. So 1 digit, after that 2 digit. So 1 is in the last digit and then 1. After that 1 digit, if it is moved, we'll get 0.011. 0.011. That's all. When we multiply this into this, and then when we multiply 13 into 0.011, how to multiply? You just forget about the decimal and then multiply the whole number. After that, leave 3 digits, put decimal over there. So when we add the value, we will get 12.011. 12.011 AMU. So, it is important to understand that if it is mentioned that the atomic mass of carbon is 12 AMU, it refers to the average atomic mass of the carbon isotopes, not the mass of the individual atoms of carbon. The average atomic mass is 12 AMU, not the mass of the individual atoms of carbon. Here 12.011 AMU is mentioned, the average atomic mass of the isotopes. Right. Thank you, children. The next one is a molecule and molecular mass. Molecule and molecular mass. Except noble gases, atoms of most of the elements are found in the combined form with itself or atoms of other elements. That means atoms of most of the elements are found in the combined form with itself or the other elements. It is called as molecule. That means a molecule is a combination of two or more atoms held together by strong chemical forces of attraction. As we seen earlier, the elements plus elements gives compound. Similarly, atoms plus atoms will gives a molecule. That's all. Here, in element and element, that is, similar kind of atoms will be joined there. Let's see the example. Here, the chemical bond, the force of attraction, strong chemical force of attraction is a chemical bond. Here, think all compounds are molecules, but all molecules are not compounds. Why? Compound means one element plus another element. But in the case of molecule, all molecules are not compounds because of molecules are classified into two. One is similar kind of atoms, the other one is different kind of atoms. So, the molecules are not compounds, but all compounds are molecules. Right, classification of molecules. As I told, the classification of molecules will be similar kind of atoms and different kind of atoms. A molecule may contain atoms of the same element or may contain atoms of two or more elements joined in a fixed ratio, in accordance with the law of definite proportions. Thus, a molecule may be an element or a compound. That means definite proportion, that means a compound containing of elements with a definite proportion. As I told you, as I given example, hydrogen is react with oxygen will give water, which is having the formula H2O only. We should not write it as H2O2. H2O2 means that is called hydrogen peroxide. So, how did we get the water here? Yes, here the definite proportion we have to take. So, if we want to get water molecule from hydrogen and oxygen, definitely we need the definite proportion. That we'll see later. Thus, a molecule may be an element or a compound. A molecule may be an element or a compound. If the molecule is made of similar kind of atoms, it is called homoatomic. If the molecule that consists of atoms of different elements, which is called heteroatomic molecule. A compound is a heteroatomic molecule. Do you know why? Because a compound is different elements are joining with the proportion. So, the number of atoms present in the molecule is called atomicity. What is atomicity? The number of atoms present in the molecule. Let me take one element molecule and one compound molecule. One element molecule is oxygen and one compound molecule is water. The formula of water is H2O and the element molecule which is oxygen is O2 because oxygen is having two atoms. Okay, so the two atoms, the number of present in this molecule. O2, how should we mention O2? Oxygen 1 and the oxygen next one. There are two atoms of oxygen bonded together. As we know, the valency of oxygen is 2. So, here oxygen is having 2 bond. And oxygen is this side also 2 bond. So, the structure of oxygen molecule will be O double bond O. Or else we can write it as O2. So, this is called oxygen gas. Oxygen gas. Not this one is oxygen atom because there are two atoms. So we can call it as oxygen molecule. Oxygen molecule. The next one, the compound. The compound I have taken as water. In this water, the subscription of this symbol is called the number of atoms. Here you can see the subscription of hydrogen is number 2 and oxygen is no number. If no number means we have to take it as 1. So totally hydrogens is 2 atoms and oxygens is 1 atom. Totally 2 plus 1 is 3 atoms. The 3 atoms are present but they are different kind of atoms. 2 atoms are similar, 1 atom is different. In the case of oxygen molecule, both the 2 atoms are similar kind of atoms. You can see oxygen structure. We can see the hydrogen structure as HOO. Yes, this is the structure of water. Here, oxygen is having 2 bonds, that is satisfied by 2 valencies, and oxygen is satisfied by their 2 valency, and hydrogen is only, sorry children, sorry, this I made mistake, just a minute. Oxygen, hydrogen is here and hydrogen is here. Okay, and oxygen is here. This is the molecule structure. So bond. Okay, that's all. So hydrogen is having single valency, that means only one valency. So it has satisfied. Oxygen has 2 valencies. So this side one, it has satisfied. In here, there are different kind of atoms present in this compound. So which is called heteroatomic molecule. Hetero means what? Different. Hetero means different kind of atoms. So heteroatomic, which means different kind of atoms. A compound is a heteroatomic molecule. So a compound means different kind of elements will be present. So definitely it is heteroatomic molecule. The number of atoms present in the molecule is called atomicity. Now you told I have written oxygen molecule. So oxygen is having 2 number of atoms. Right? So what is the atomicity? Atomicity of oxygen will be 2. That's all. Here atomicity is given. If atomicity is 1 means the number of atoms is 1. So the name we have to give it as mono. If it is 1, we have to give the name mono. The atomicity is 2, the number of atoms is 2. And if it is a 2, the name will be di. diatomic. If the number is 3, atomicity is 3, the number of atoms are 3. We have to call it as a triatomic. If it is greater than 3, we have to call it as polyatomic. If it is a 4, and it is called a tetra, and if it is a 5, it is called penta. It is called penta. So 4 and 5 we can mention it as polyatomic molecules. Polyatomic molecules. Let us consider oxygen gas. Oxygen, right? We are going to consider oxygen. Oxygen gas exists in two allotropic forms. One is O2, the other one is O3. So the oxygen exists in two forms. One is O2, the other one is O3. What is this O2 called? Normal oxygen gas. What is this O3? Ozone. So in oxygen molecule, both are molecule because of the number of atoms are more than 1. Right. There are 2 oxygen atoms in oxygen molecule. So its atomicity is 2 and both the atoms are similar. You can see both the atoms are similar. Whose atoms? Only oxygen's atoms. So oxygen O2 is a homodiatomic. If it is a similar kind of atoms are present, we have to give a name it as homo. How many atoms? 2 atoms. The name should call it as diatomic. So homodiatomic molecule. The other element which is O3 children that exist in as diatomic molecule or yes the other like oxygen, how many elements are exist as diatomic molecule? Right, you can say the other gases which is hydrogen and nitrogen. Hydrogen is a gas, nitrogen is also gas. So hydrogen can exist in H2, nitrogen is N2. Hydrogen, the structure will be, we can write it as HH, but in the case of nitrogen, we have to write it as N triple bond N because of the valency of nitrogen is 3. So 3 valency should satisfy. Right. Fluorine, chlorine, bromine, everything are gases. The halogen family which are gases. So we can write it them also F2, Cl2 and Br2, I2 like that. In the case of ozone contains 3 oxygen atoms, and hence it is called homotriatomic molecule. Homotriatomic molecule.